We're going to compare the destructive energies of conventional bombs and the nuclear bomb, the Hiroshima bomb. Why do we want to do this? We want to do it to look at the issue of size and scale as before, due to the great variation of the energy and its destructive release and detonation of nuclear bombs. And also in this case, we want to look at policy, because these numbers will help us make the ethical decision of whether we should have dropped the atomic bomb on Japan or not. We encapsulate our problem of comparing the energies. Conventional bomb here, that's the 20 kiloton estimated yield of the firebombing of Tokyo March 9, 1945, to the Hiroshima nuclear device detonated on August 6, 1945, with a yield of 15 kilotons. Here's the setup for the solution to the problem. First of all, we need to find the yield for each of the bomb types, conventional and nuclear. How do we do that? Well, this yield, we have to look it up, so we can do that on Google. Then we can convert our yield to joules by conversion factor we've seen before. Then we take the ratio of those two. Hiroshima to conventional to drive our ethical decision. Energy Hiroshima, follow the setup. The yield is, we know it from before, it's 15 kilotons. 1.5 times 10 to the 4 tons of TNT. Now we convert. We know what 1 ton of TNT gives. That many joules. Multiply by the number of tons and we get the total energy, which is 1.5 times 4.2 is 6.3. Now, multiplying the powers of 10, we do that by adding the exponents as before. 4 plus 9, 13. And there's our answer for the energy. Okay, we're going to compute now the energy release of conventional bombs. The yield estimated from Google, 20 kilotons, 2 times 10 to the power 4 tons. Convert that to energy, multiply by our well-known conversion factor right here, and multiplying the whole numbers, 2.0 times 4.2 is 8.4, as opposed to the powers of 10, and 10 to the 4 times 10 to the 9, adding exponents, 10 to the 13, number of joules released by this conventional bombing rate of 1945. With all what we've done, we can now compare numerically the ratio of the energies released for the conventional bombing and the Hiroshima bombing. And we can see from the slide, Hiroshima, 6.3 times 10 to the 13 joules, estimated conventional, 8.4 times 10 to the 13 joules. Take the ratio, and we get this factor, and we'll simplify it. Okay, we simplify the ratio. There it is, 6.3 times 10 to the 13 over 8.4 times 10 to the 13. We'll split off the decimal numbers here. 6.3 over 8.4, common factor of 2.1, so that's 3/4. Now let's look at the powers of 10. 10 to the 13 divided by 10 to the 13. What does that equal to? Well, we can do it in two ways. First way, let's use what we know about division and subtracting exponents. So, exponent 13 divided by 10 to the 13, subtract the exponents. Subtract 13 from 13, you get 0, which is 10 to the 0. What's that? Well, we know what that is because this whole piece is something divided by the same thing, which is 1. So the ratio of the Hiroshima blast to the conventional firebombing is 3/4, or if you want, they're about the same. What are the implications ethically? In conclusion, we have the solution to our problem. First, why did we do this problem in the first place? Well, one thing is to get more practice involving scale and the calculations and the numbers involved. Very important in our study of the relative strengths of nuclear weapons and nuclear weapons versus conventional weapons. The other thing is, more importantly, we are now looking at the ethics of this whole issue of dropping the atomic bomb on Japan, because the destructive power, the destructive energy, not power, remember power is energy divided by time, the destructive energies of Hiroshima bomb and the firebombing raid were about the same. And about the same number of people were killed, estimated about 100,000. So it appears that there's no ethical question here. But we've neglected some very important things in the analysis. We just focused on the destructive energies. We have neglected radiation effects, whose effects linger for tens of years after the actual blast, and many more people died, perhaps another of the order of 100,000. It's very hard to estimate. The concentration of destructive energy was vastly different. One bomb, one drop, versus 9 hours of bombing, thereabouts, by the B-29 superfortresses. The effect of both of these has a great impact on our psychological perception of the bombing, and therefore affects our ethical decisions.